When examining the controls on a page, you'll notice three directives playing crucial roles.
The first, the form control name directive, registers the form control instance within the form group, establishing a link between the form control model and the native control. Similarly, the ng model serves a parallel purpose. In the realm of template-driven forms, the any control status directive tracks form control statuses such as validity, dirtiness, or touch, dynamically applying CSS classes to the associated node. Now, the third player in this ensemble is the default ValueAccessor.
It's important to understand that each form model, like a form control, typically maintains a one-to-one relationship with a corresponding native control, such as an input, text area, or select. We utilize directives like form control name for reactive forms or NE model for template-driven ones to establish these connections. However, establishing a connection alone isn't sufficient for seamless functionality.
Proper synchronization of states between the form control model and the native control is paramount. Consider scenarios where a value is set on the model side, necessitating a reflection of this change on the view side. Conversely, if a user modifies the input value in the view, this change must be captured in reform control model. Here, the ValueAccessor steps in, handling the synchronization of states.
The key states include value change from model to view.
The write value method of the ValueAccessor is invoked when a new value is set on the model side.
Disabling state.
The setDisabledState method manages the synchronization of the disabling/labeling state between the model and the native control. Change from view to model. During the initialization of directives like ngModel or form control name, the registerOnChange method of the ValueAccessor is called, providing a function to be invoked whenever the user modifies the value. This ensures synchronization from view to model.
Touch state.
The registerOnTouched method, also called during initialization, provides a callback function to be invoked when the native control is touched, e.g. on blur. This manages the synchronization of the touch state.
Why the need for a separate abstraction?
Well, it ensures a cleaner, more extensible design. Different types of controls have distinct behaviors and APIs. By abstracting the synchronization logic into the ValueAccessor, we avoid an unwieldy if-else tree within the directive and adhere to principles like single responsibility and open-close design. This approach allows for the seamless integration of new control types without modifying the existing directives. In essence, the ValueAccessor acts as a bridge, facilitating the harmonious exchange of states between the form control model and diverse native controls, supporting not just built-in controls but an infinite variety of custom components with unique functionalities.
All these diverse entities need only adhere to the common control ValueAccessor interface.